here I can fill out my table using my equation and graph this. So when I plug in x is -3, I get +7. X is -2, I get +5. X is 0, remember we should always include that coordinate on our graph. X is 4, y is equal to -7. So graphing this, -3, +7, -2, +5, 0, 1, 4, -7, somewhere around here. It gives me my straight line pattern. Okay, so I could, when I look at this, if we recognize where the slope and y-intercept is, it helps us a lot with how we can graph this equation. Okay, so it's important to connect this idea of what parts of this are slope and where do I see slope in the equation, the table, and the graph. Okay, so when I talk about the ratio of change, I can see the ratio of change in the table like this. So I have a ratio of change of -2 to +1. I can see that -2 and +1 in the slope triangle. Okay, so the slope here is the change in y over the change in x. So as a one number slope, it's equal to -2. The y-intercept is going to show up as x equals 0. So y-intercept is y equals 1. It shows up on my graph there, it shows up on my table. It also shows up there, just like the slope shows up in the equation. Okay, so these are things I want you to connect to each other. So here I could fill out the table from the graph. So remember that equations, tables, and graphs are all related. So if I start with a graph, I can fill out my table. Okay, so I have -6, +6. That +6, -6, +6, -3, +4, 0, 2, 3, 0, 6, -2. Okay, and I can come up with my equation given just this picture here by showing my change in x or change in y. That's going to be down 4. In this case, it's going to be +6. Okay, so the slope is the change in y over the change in x, -4 to +6, or -2 to 3. The y-intercept is going to be that point there. It's going to be that coordinate, which is at 0, 2. Now, if I want to come up with my equation now, I can write my equation as -2/3 x plus the starting point of 2. And that allows me to connect this idea of slope, okay, that I see in my graph, my table, my starting point that I see in my graph and my table, onto my equation. So here's a word problem. And again, even in the word problems, we still need a rate and a starting point. Okay, so here I have a bus traveling at 30 kilometers an hour, and it starts at 5 kilometers from the school. So the quantities being related are time and distance from school. So which is the dependent? The dependent is distance. Okay, and so if I were to make a table of values it starts at 5 kilometers, so at 0 hours I'm at 5 kilometers. And let's say we went for 2 hours, so let's go in half-hour increments. So at 0.5 hours, at 30 kilometers an hour, I've changed 15 kilometers, so I'm at 20. At 1, I'm at 35. 1.5, I'm at 50. Okay, so I'm going to mark my increments here. So this is going to be 1 hour. Let's say that's going to be 2 hours. Okay, so that's going to be 0.5 and 1.5 here. My distance we'll do in let's do in 5, so let's say that's 25, and let's say that's 50 kilometers. Okay, and we can plot our points here, so we know that that's going to be starting at 5 kilometers, we're at 20 kilometers, 1 hour we're going to be at 35 kilometers, so 1 hour we should be 35, somewhere around here. Okay, oops, that's going to be right there. Okay, 1.5 hours, we're at 50 kilometers, so that's going to be right about there. And again, these points line up. We have a straight line relationship that has slope and a starting point. Okay, this slope ratio, if I look at the slope ratio, it's 15 kilometers every half an hour, or 30 kilometers an hour. So the ratio change is going to be 30 kilometers to 1 hour, okay, which is our rate. So it's going to be the slope, which is 30 kilometers per hour. The starting point is at 5 kilometers, and based on this starting point and rate, we can write the relationship as the distance is equal to 30 kilometers an hour times the number of hours starting at 5 kilometers. Okay, or y is equal to 30x plus 5.